last thing you want to know is that you lost your data. I remember shooting all day long with my camera, and I was lazy not to transfer the videos for many days. And when I tried, the memory card failed. I lost those files. From then on, I ensure keeping a few copies every time I shoot. Even worse, if you can't figure out how to retrieve your files from the backup because it's not organized. So when dealing with data, regardless of whether it's an individual, a professional, a small business, or an enterprise, you need a well-organized backup, and that's what we'll focus on today. My name is Kumar Nachiketa, and I am a Storage Partner Solutions Architect at AWS, and today I will explain how AWS Storage Service can help build a cost-effective, highly secure, and reliable solution, and improve your backup and recovery workflow. Topics I'll cover today on the screen for your quick look. So let's cover some basics before we get into backup and recovery approaches with AWS. So by now, you would agree that data loss can be costly, right? For some organizations, data loss means a poor customer experience, and for some, even a few minutes or hours of data loss means millions of dollars of revenue loss. Or it could end up breaching some compliance requirement, so you want to avoid it. And the way to start planning a backup solution for your workload is by defining RPO, recovery point objective, and RTO, recovery time objective. So one of the goals of protecting data is to minimize data loss in the event of failure. And the way to measure it is by defining the RPO, recovery point objective. It can be as low as 0, which means no data loss, or it can be a few minutes to hours or even days. So basically, you are defining how much data you are willing to lose from the point in time of failure. In the ideal world, you wouldn't want to lose any data, right? But you define the RPO of your workload based on its business criticality. The second thing to define upfront is RTO, recovery time objective. It means how much time you expect to spend in recovery and bring your application up in the normal state from failure. RTO can also be as low as 0 for highly critical application, which means recover automatically from the failure and instantly. However, in my experience with the backup solution, it is usually in minutes to several hours. As I said earlier, you wouldn't want to lose any data in the ideal world in the event of failure. You would also like to recover instantly, but this means the cost of protecting data will also be very high. In reality, every organization has different types of workload with a diverse level of criticality. That's why you define different level of SLA, RPOs, RTOs, and manage cost versus liability. When you plan to include AWS Storage Service in your backup solution workflow, start by answering these questions. How critical are the applications to your business? Identify whether the workload is highly critical and any outage could potentially bring massive disruption to your business. For example, your production environment. A non-critical workload example may be a test environment where some outage will not disrupt the business in the same way as production. And based on that, identify the RPO and RTO of the workload. How are you storing the data? So for example, do you have backup software that is centrally backing up all the workloads? Or do you use some in-house script or application-based backup? And in many cases, you may have different backup methods coexisting in your environment, even multiple backup software, maybe one for your virtual server, another for a physical server, and maybe another for your cloud workload. In my everyday conversation with customers and partners, I see this very regularly. This information will help you determine ways to integrate AWS storage services in the backup workflow. Where are you storing the data? So are you storing all the data on disk or still using tapes? Or it's a mixed environment? It'll help identify the right storage target and also help to determine any need for migration. Finally, are there any compliance considerations? You might be required to keep data for a specific duration in many regulated industries, say 7 years, 10 years, or even an indefinite timeline. Making sure you have evaluated such requirements upfront is crucial. Another thing to consider is that as you begin your cloud journey and start migrating applications to AWS and start using AWS native services such as Amazon EC2, RDS, DynamoDB, Redshift, and many more, the data protection strategy for cloud native workload changes. For on-premises workload, AWS Partner Solution and AWS Storage Services are part of the solution. For cloud native workloads, along with the partner solutions, you can use AWS Backup. All right, let's look at the traditional backup approach and how AWS Storage Services increase backup workflow efficiency. First, I will cover on-premises workload protection and utilizing AWS Storage Services in a hybrid setup. Later, I will cover the strategy for the cloud-native workload protection. So here we have the application servers. Think of that as varieties of workloads, virtual machines, physical servers, databases, and consider these as the backup clients. And typically, you have one or more backup servers in the on-premises environment. And now, based on the backup policy, you store the backup data in the local disk for faster recovery and long-term retention data in the tape. By the way, it's common to see many organizations already move to all disk-based storage for backup. These are also referred to as purpose-built backup appliances. And it has been common to have an off-site vaulting. The tapes are shipped to a secondary site for long-term archival, or sometimes it's also done due to a compliance requirement. Now, let's divide this architecture into two sections to clearly understand how AWS can improve backup architecture in a hybrid setup. So on the left, you have the workloads to protect and backup server. And on your right, disk and tape storage where backup data is stored. So as you see on the left, backup server, which has a backup software, which helps centralize the backup, maintains policies and catalogs for all the on-premises workloads. It also helps to provide consistent application backup, and many backup software also offers features such as deduplication. Customers tell us that they mostly like the feature backup software offers, and they want to retain such features and maintain the backup and recovery workflow for the on-premises workload. The real issue is on the right side. If your business is growing, backup data is increasing at an exponential rate as well. And maintaining on-premises storage brings several challenges, including capacity management. You have high upfront cost. Also, tape management has its challenges. Every 2 to 3 years, you have to deal with hardware refreshes and plan for the migration. And overall, the maintenance of storage consumes valuable resources, both human and IT infrastructure. Let's see how we can improve this backup workflow with AWS Storage Service, particularly with our object storage service, Amazon Simple Storage Service S3. And just before we dive deep into the backup, a glance at the overall AWS storage portfolio. We have a full range of storage services to match every application storage requirement. In object storage, Amazon Simple Storage Service S3 and S3 Glacier. Amazon Elastic Block Store EBS for block storage, Amazon Elastic File System EFS, and FSx family in the file storage. AWS Backup, primarily for cloud-native workload backup, and then the range of services for the data transfer and edge processing. And the Snow family is for the offline data transfer requirements where network bandwidth is insufficient. For today's discussion, Amazon S3, AWS Backup, and AWS Storage Gateway, specifically Tape Gateway, are highly relevant. And as we go along, I will be highlighting these in more detail. And let's start with one of the most important services, our object storage service, Amazon S3. A few essential aspects that are particularly relevant for storage you want to use to store backup data. Amazon S3 is highly available, 11.9 durable, and you can virtually scale unlimited. These are super important aspects of backup storage. It's very tough to achieve such durability and scale with on-premises storage. Moreover, S3 is purely pay-as-you-go with no upfront cost, unlike on-premises storage. Keeping data secure and restricting access by using granular control is very important. You can easily achieve it with S3. You can choose different encryption methods, server-side or client-side. Also, S3 integrates with our key management service, KMS. You can use features like Object Lock to meet compliance requirements with S3 Object Lock. You can store objects using a write once, read many worm model. You can use it to prevent an object from being deleted or overwritten for a fixed amount of time or indefinitely, which is highly desirable in regulated industries and helps build a recovery strategy against a cyber attack. You have very granular auditing capabilities with CloudTrail integration. Based on the retention requirements, you want to choose the right and cost-effective storage type in a backup solution. Amazon S3 offers a range of storage classes designed for different use cases. So you can match the cost based on the data retention and access pattern of backup data. Let's spend some time understanding different storage classes. As you see, these are the range of storage classes. S3 Standard for general purpose storage for frequently accessed data. S3 Intelligent Tiering for data with unknown or changing access patterns. S3 Standard Infrequent Access and S3 One Zone Infrequent Access for long-lived but less frequently accessed data. And Amazon S3 Glacier and Amazon S3 Glacier Deep Archive for long-term archival data. Notice if you move from left to right, the storage per GB cost gets lower and the classes become more suitable for less frequently accessed data. For example, S3 Glacier and Glacier Deep Archive can be the right storage class for archival data based on the retrieval SLAs and often used for tape replacement. All right. Now we know that S3 is a perfect place to store your backup data. Let's see how the overall backup workflow improves by replacing on-premises storage with Amazon S3. So again, revisiting the traditional backup architecture, the one in green represents the workload to backup and backup server. The chances are high you are using one of the backup software included in the URL below. It is a list of storage ISV competency partners that integrate with Amazon S3 for the backup use case. Competency partner solutions have gone through our well-architected review. So you will either retain or make minor changes, say upgrading your backup software to the latest version, or in some scenarios, you will replace if the current solution does not provide the kind of integration you need. We will significantly change the architecture on the right side and use S3 to meet your backup storage requirement. And with all the change, this is how your target solution will look. So in your current backup workflow with these changes, now Amazon S3 is integrated. 4 main changes here, and we will dive deep into them one by one. So you select one of the AWS regions, choose a networking method, and use an appropriate S3 class, create a bucket or buckets, and you get going. You use backup software native Amazon S3 integration, which is a backup server's ability to write to S3 directly, or use Tape Gateway, which appears as a virtual tape library to your backup server. And finally, in this solution, you can also minimize the overall storage allocation on premises for the backup store by reassessing backup SLAs. All right, so let's look at these 4 changes to improve backup workflow one by one. And the first one, we replaced the truck which was sending tapes offsite by networking to connect to the AWS region. You can design this to be way more reliable and secure than sending it via truck, right? So you need to assess how much data to back up and send to AWS regularly, for example, change rate, etc. And based on that, you could be choosing one of the methods, AWS Direct Connect, VPN gateway, or the internet. If the customer needs to migrate a massive amount of data initially, they can use Snow family, Snowball or Snowmobile, to migrate the data even in the petabyte scale. Let's spend some time on the second change, the storage portion. Now you are using Amazon S3. You use Amazon S3 Glacier or Amazon S3 Glacier Deep Archive for long-term retention data, where the restore frequency is rare, but you want to retain the data for a long time, like 3, 5, or 10 years. Or you use S3 Standard or S3 Infrequent Access for operational recovery data based on the frequency of retrieval requirement. Once the data is in S3, that can be used for more things. And most backup software can restore the data within AWS, which can be used to migrate the workload or even use occasional test, or this can be used as one of the DR approaches for specific workload. So let's talk about the third change, how backup software could write the data to Amazon S3. So there are 2 options. One uses native Amazon S3 integration, your backup software's ability to write to S3 natively using S3 API. And most of the industry-leading backup software, as I mentioned earlier, and here you can find in the URL below, has integration with S3. The URL lists the competency partner. If your backup software isn't listed here, you should still check from the vendor for the level of integration with AWS. The other method uses Tape Gateway. Tape Gateway enables you to replace using physical tapes on premises with virtual tapes in AWS without changing existing backup workflows. Let's dive a bit deeper into Tape Gateway, how it works. So this is how Tape Gateway works. Virtual tapes, tape drives, and media changes are presented via iSCSI to the backup server. The backup server writes data to virtual tapes, which are stored in Amazon S3. When it ejects the tape from the virtual tape library, the gateway marks the tapes as read-only and archive them to your choice of archive class, Amazon S3 Glacier or Amazon S3 Glacier Deep Archive. Tape Gateway supports all leading backup applications and caches virtual tapes on premises for low latency data access. Tape Gateway encrypts data between the gateway and AWS for secure data transfer. These are the backup software which support Tape Gateway. It might not be obvious to decide which method to choose: backup software native S3 integration or AWS storage gateway. So let me give you some ideas to help you evaluate. Backup software's native S3 integration has some inherent benefit. As it is natively integrated with the backup software, you may not need any additional appliances. In most cases, it supports advanced features such as data deduplication. If the level of your backup software integration meets your backup requirement, go for the native integration. And what do I mean by the level of integration? Say you have a long-term retention requirement for your monthly backup, and you want to retain it for 10 years. So it would need your backup software supporting archive classes, S3 Glacier and S3 Glacier Deep Archive. Also, if you are going to use some of the advanced feature from S3, say S3 Object Lock, does your backup software support this natively? Now in AWS Storage Gateway, the benefit, it's drop-in replacement. Say you can't make any change in the backup configuration. Example, the current version of your backup software cannot be upgraded due to the dependency. Maybe you need to write on S3 Glacier or S3 Glacier Deep Archive, and backup software don't support natively. So you can choose Tape Gateway. You might need a gateway appliance with local cache or feature support such as write once, read many, worm, and tape retention log. The last point or last change in this backup architecture with S3 is that you can minimize the local disk capacity usage. You are using Amazon S3, which has storage classes to support different access patterns. So I see many customers reassessing their storage requirements, keeping the absolute minimum for regular operational recovery requirement, say store daily backup for 14 or 30 days on the local disk, and the rest of the data in S3. It helps to minimize the on-premises storage cost drastically. So we improved the backup workflow for the on-premises workload. Gradually, you move your workloads to AWS and you need a different backup strategy. Let's see how you tackle it efficiently. So as you start using AWS services such as Amazon EC2, RDS, DynamoDB, EFS, and more for your cloud-native applications, you assess your data protection requirements, and you can use the AWS Storage Partner solution. For the AWS Partner solution, you determine what AWS services it supports and whether you are looking to centralize backup management for on-premises and AWS workload. Each partner solution offers a unique capability, and you can find out more from our partners. You can also complement the backup strategy with AWS Backup, and for the remainder of the session, I will cover AWS Backup. AWS Backup is a fully managed backup service that makes it easy to centralize and automate data protection and the backing up of data across AWS resources. At launch in January 2019, AWS Backup supported 5 services: Amazon DynamoDB, EBS, EFS, RDS, and AWS Storage Gateway. Since then, AWS Backup has been continually adding AWS services and new features as per our customer demand. So now, in addition to the 5 services, AWS Backup supports Amazon FSx for Lustre, FSx for Windows File Server, EC2 Instance Level Backup, and Amazon Aurora. You can create backup policies and plan. You tag them. You can use them to define your backup requirements like frequency and retention and expiration of all those backup copies. And you do all this in a policy-based way. Few key features to note: it supports AWS organization. You can manage cross-account backup, which helps build a solution against multiple threats such as cyber attacks. On your screen is the support metrics for AWS Backup service. While all services supported by AWS Backup offer centralized management and control capabilities and the ability to manage backup operations and centrally orchestrate across services, for EFS, it also provides advanced feature at a more granular level in our APIs, including a separate storage tier and the ability to lifecycle backup from warm to cold storage as per a set policy. Currently, only EFS offers advanced feature, but we plan to fill out this chart both vertically and horizontally in time. Alright, it's time for the AWS Backup demo. Alright, let me take you through AWS Backup demo. So in this demo, this is what I will cover. First, a basic walkthrough of AWS Backup via AWS Console. Then I will show you how to create a backup plan. We will then see how to make recovery points highly secure with AWS Backup. I will then create an on-demand backup of an EFS file system and finally recover the EFS's deleted data. I already have some resources created, a web server and an EFS file system with images. So I have logged into my AWS account, and this is the AWS Backup Console homepage. How does it work? You create a backup plan, define all the requirements, assign the resources you want to backup, and then manage using AWS Backup. Let me click on the dashboard, and here you can see the overview. So here you can manage the backup plan, create an on-demand backup, or restore the backup. You can see all the backup and restore jobs and drill down further. Let's click on backup vaults. In AWS Backup, a backup vault is a container that you organize your backup in. So you see I already have some backup vaults created here. Let me open a vault here. So you can use a vault to set the AWS KMS encryption key, configure access to your backup vault, and protect resources by managing access policy permission. Let's click on the backup plans now, and I have one backup plan already configured. Let me click to open this one. So here you can define your backup requirements, including backup schedule, backup retention, and rules. If I click on this backup rule, you can see the backup frequency and other configuration, and also assign the resources. I can see all the protected resources here. See, I have some EBS, EFS, and EC2 resources already. And all the job details here. As you can see, I already have some completed jobs. All right, let me show how you can create a backup plan now. So click on backup plans and then click create backup plan. I will select build a new plan, enter the backup plan name, enter the rule name, schedule frequency. Let's select custom cron expression. This will allow the granular configuration of backup frequency. So let me enter this here. Backup window, leaving it default, so the expire to setting the expire to 4 months. This will set the length of time backups are kept as part of this rule. Now select the backup vault. I am selecting backup workshop Gold vault. Finally, click create plan. So we have a backup plan with a backup rule. However, we have no resources assigned to be protected by this plan. So let's click the assign resources button here. In the assign resource pane, select assign by 2 tags and set the key to backup and the value to gold. Doing this will instruct AWS Backup to protect resources such as EFS, EBS by identification based on tag. Click assign resources to save the resources assignment, and from the AWS console, select services and then EC2. I will click on volumes. For the demo purpose, I'm selecting a random volume here. Let me select admin console root volume. Click on tags. Click the add edit tags button. Enter the key name, backup, and the value gold. And save to create the new tag. So I have now successfully created a backup plan that will take hourly backups of any supported resources within my account region with a tag named backup with the value gold. Next, security features with AWS Backup help ensure that backup will be managed only by those who should have the privilege to do so. Let me show how AWS Backup stops users with elevated privilege from deleting backups in the console of source services such as EC2 and EBS. So I'm already on EC2 console, so let me select snapshots. Here's it's a list of snapshots created manually, and by AWS Backup. So if the snapshot description states this snapshot is created by the AWS Backup service, then AWS Backup has created it and will keep it secure. Let's test this by attempting to delete a snapshot that was created by AWS Backup. So right-click here. Notice the description says this snapshot is created by AWS Backup service. So let's click delete. Let's confirm. Yes, delete. See the error message? This snapshot is managed by AWS Backup and cannot be deleted via EC2 APIs. So despite having administrator access, I am unable to delete the snapshot. So you see, AWS Backup secures snapshots, recovery points from being easily deleted within the services it protects. There are many ways to secure backups with AWS Backup. The granular control allows you to lock down action and backup resources with fine-grained control. All right, now let's create an on-demand backup for an EFS file system. I already have a web server configured which uses this EFS file system to host images, as you see here. So I will back up this EFS file system, then delete all the images from the web server, and then will restore using AWS Backup. So let's create an on-demand backup first. Let's go to the AWS Backup console again. On the dashboard, click Create an on-demand backup. In the resource type, you see we can select any of the resource type. We'll select EFS, enter the file system ID. I can also find it from here. Here's my web server EFS file system, and done. Select Create Backup Now here. From the Expire drop-down, select Days After Creation and select 3. From Backup Vault drop-down, select Backup Workshop Silver Vault. Now click Create On-Demand Backup to start the on-demand backup. So it will take a while. We will let the backup complete. I will then delete the data from the web server. All right, so the backup is now complete. Let me delete all the EFS data now. So this is my web server SSH session. Let me run the rm command to remove all the images. And done. So the images are deleting. To confirm, let me go back to the web page. And as you can see, there's no file anymore. Let's restore those files now. So from the AWS Backup dashboard, click Restore a Backup. In Protected Resources, you see the resources and last backup. I click on my EFS file system. I am selecting the most recent recovery point for the EFS file system and click Restore. Leave the default options on the Restore Backup pane. Full restore, you see, you can perform item level restore as well. Restore location, leave it as restore to the directory in the source file system, and click Restore Backup. So the restore process will start after some time, and then the file data will be recovered back into the mounted EFS file system on the web server instance. So you see here, it's in the pending state now. We will come back later once the job is completed and inspect the recovery. All right, the restore is successful. Let's go back to the web page to check if the images are back. And as you can see here, all the images now are back. All right, so this concludes the demo. As a key takeaway, start with defining your application requirement, defining RPO and RTO, and answering some basic questions we discussed in the beginning. For the on-premises workload, backup to the cloud using AWS APN partner backup software and Amazon S3 to improve backup workflow efficiency. And finally, as you move workloads in AWS, start using AWS Backup for the cloud-native workload protection. Before I wrap up, we offer several digital trainings, including 550 plus free digital trainings to help you learn your way. I highly encourage you to explore and enroll in the topics of your interest. I hope you enjoyed my session, and please remember to complete the survey. Let us know what you think and how we can improve the event experience for you in the future. Thank